Welcome to our sixth PyHealth live tutorial. I'm presenter Zhenbang Wu. I'm currently a PhD student at UIUC. In today's tutorial, I will introduce how you can use your custom dataset with PyHealth and make the model training and model inference much easier. So first of all, let me introduce the development team. So we are from Professor Sun's lab at UIUC. The core developers include Chaoqi, me, Patrick, and Jen. And we also want to say special thanks to our external collaborators, Yue Zhao, Dr. Zhi Qiao, Dr. Xiao Cao, and Xiyang Hu. So without further ado, let's get started. First of all, for those who are new to PyHealth, I want to give you a brief overview of PyHealth. So basically, PyHealth is a deep learning toolkit for healthcare. It is developed for both domain scientists and also for machine learning researchers. So PyHealth has these four features. The first one is that we provide the API to several popular EHR databases that can be incorporated into a downstream task very easily. And secondly, we also provide the APIs for different prediction tasks, both in terms of some patient level prediction tasks, visit level, and also some intra-visit level tasks. And thirdly, which is also our core module, that is the model part. In PyHealth, we provide more than 10 state-of-the-art machine learning models for specifically developed for healthcare that can be used with just a few lines of code. And lastly, some of the students from the UIUC course already learned there exists multiple medical coding systems in EHR data, and mapping among those coding systems is actually a very tedious job. So in PyHealth, we provide this functionality of code mapping between different coding systems, and also the code looking up within one coding system, and also to some important external database. And so a few weeks ago, we discussed the basic data structure of PyHealth. That is, we will convert different popular EHR datasets, such as MIMIC, EICU, or OMOP data using PyHealth to this standard data structure. That is this hierarchical structure you can see on the right. At the very top, we have different patients, and each patient has multiple hospital visits. And further, each hospital visit will contains different events. It can be diagnosis events, procedure events, treatment events, or lab events. So that's already covered in previous tutorial. If you want a recap, you can go to our YouTube channel and watch the recording. And for today's tutorial, I will introduce how we can adapt some custom data set that you are interested in into PyHealth. And after that, you can use the other pipeline of PyHealth and make model training inference much easier. So let's get started. So as a high-level overview, there are three ways to process custom dataset in PyHealth. The first is that you can convert your dataset into OMOP standard format. So I will next introduce what is OMOP standard format. And the second way is you can do the pre-processing on your own and return a list of samples. And PyHealth will take those dictionary-based samples, and then you can use it you can use PyHealth other modules like the model part, the trainer, and the evaluator. And the third way is that you can create your own dataset class. That is, you can inherit our base dataset class and then create your own. So let's start with a real-world example. So heart failure is a very common and also severe disease, and it accounts for significant and growing healthcare expenditures. And the early detection of heart failure is very important. It can not only improve healthcare quality, improve the patient safety, and also reduce the overall healthcare cost. So we will take a look at this. We define this early heart failure prediction as a deep learning task. So if you take a look at this patient showing this diagram, so it has patient ID 12853 and gender, age, that's the demographic information of this patient. And in terms of the medical information, as shown here, this patient has 4 visits in total. And for each of the visits, the EHR records a few different medical codes. For example, in the first visit, the patient has disease cough, and it was prescribed with some medications for this symptom. And for the second one, the patient developed fever and pneumonia and was given chest X-ray. And for the third one, the patient was diagnosed with chest pain and was given some pain reliever. And in the very last hospital admission, the patient is diagnosed with heart failure. So the question or the task we want to do here is that can we use a neural network or train a neural network to detect heart failure as early as possible? For example, can we detect the heart failure after the third admission of this patient? So now we have defined this task. Let's first discuss the first way we're gonna do to use PyHealth to do this task. As I mentioned earlier, the first approach is that we can convert your custom data set into the so-called OMOP standard format. So what is OMOP standard format? So basically, OMOP standard format, it defines a unified API for sharing and transferring medical data. That is different. That is medical data from different sources, like different hospitals or healthcare institutions, has slightly different format compared to each other, and that's not shareable among each other. And what OMOP do is it defines this common data model that transform heterogeneous medical data format into a homogeneous one that can be used together for analysis methods, and also their results can also be comparable. And more specifically, here on the very right, I show the standard API of OMOP. As you can see here, it is essentially a relational database where the main table is the person table. And this patient table is linked to different subtables like this visit occurrence. And each visit occurrence will have different condition, different drug, different procedure. So what we can do here is we can convert our customer data, that is this sample data shown on the left, to the standard OMOP format. That is, we will convert this patient information to the person table, this visit information to the visit occurrence table, and those different types of medical codes into the corresponding medical info. As you can see here, the conditions are linked to the condition occurrence table. The medication is linked to the drug exposure table, and the procedure is linked to the procedure occurrence table. So after we convert those customer data into OMOP standard format, we can then use PyHealth OMOP dataset to read the data and then apply it in different downstream tasks. So in this Jupyter notebook here, I load the dataset I just mentioned earlier. That is this heart failure prediction dataset. And as you can see here, we list this dataset has a event CSV files and the heart failure events CSV files. So basically, this data follows the format that I just mentioned earlier. That is, each patient, we have multiple visits, and each visit has different medical codes, and it is stored in these two tables. So since this is a custom data set, PyHealth cannot directly read this data set. So we will use the first approach to convert this data set into OMOP standard format. So to do this, as you can see here, we first create this person table of OMOP, and then convert the corresponding patient information to this patient table. The converted result is shown here. We record a corresponding PID to the person ID column in patient table. And for now, that's all we needed. OMOP has some other information, but right now, let's just take a look at this very simple example. And very similarly, we will store the visit information to the visit occurrence table. This is visit ID, and also this death information in the death table. But since this data set is for heart failure, we didn't record any mortality information. And we do the same for different medical codes. So for the condition, we store the conditional code into the conditional occurrence table. And also it also contains the person ID and also the visit occurrence ID. And that's the same for the condition, for the procedure, and also for the drug. And now we have already converted our custom data set into the OMOP standard format. That is those relational table, and we store it in the disk. So right now, as you can see here, I stored so previously the dataset has different event CSV file and heart failure CSV files, and now I converted it to OMOP format. That is this 6 tables shown here: the person, visit occurrence, death, and different tables for different types of medical codes. Now, since we have converted to OMOP format, we can use PyHealth to directly read this converted OMOP data, as you can see here. This process will take some time, but as you can see here, we have already adapted this custom data sets to PyHealth by converting to the OMOP data format. And then we can simply use this dataset object for any downstream task and apply it with different models provided by PyHealth. So that's the first way to use PyHealth. As I mentioned earlier, in some cases, converting any custom data to OMOP can be very difficult, and it's also a very tedious process, considering you have to do this mapping from tables to tables on your own, and it also involves a lot of concept mapping, those medical code mapping. It can be very tedious. So in some cases, you may think, I don't want to convert to OMOP. Maybe I want to write my own pre-processing code. Can I still use PyHealth for that? And the answer is yes. So we provide you the second approach, that is, you can create a list of dictionary-based samples and convert it and directly use those samples with PyHealth. So as you can see in this figure here, that's the same example patient we have. And all you need to do is generate samples on your own with your own pre-processing code, and then adapt and then feed the list of samples into PyHealth. And we directly provide an API for doing this. So in this second approach, what you need to do is to create a list of dictionary-based samples. So the samples here has the same terminology as the samples in machine learning. There is a single data point that will be fed into a deep learning or machine learning models. So here, as you can see, I write this create samples function, which takes in the original two CSV files or panel data frames. And what I did here is I incorporated all the pre-processing code into this function. And this function essentially will loop through every patient we have in the original customer data set and create the corresponding sample as a dictionary, whose key is the corresponding feature name, and the value is the corresponding feature value. And at the very end of this loop, I will just append this dictionary-based sample to a list and return this list of samples at the very end of this function. So if we run this function, as you can see here, if you look through the CSV files to create samples, and if we take a look at the first sample created, it contains essentially the information we needed. That is the patient ID, the visit ID, and it contains a list of medical codes. As you can see here, this medical codes is a list of lists, where the list at the second level indicate visits. So now we can directly feed these samples into PyHealth format and then use it for any downstream task. There should be another cell here, but I think it get deleted during the previous round, but it doesn't matter. So what you need to do is you can just call this sample dataset and then just feed in the samples we just created. So as you can see in the API here, this is sample dataset takes in a list of samples. And that's exactly the same. That's exactly the samples we just created. So all you need to do is do this, and this will directly, and this dataset is accessible by PyHealth. And you can then use this dataset object with PyHealth downstream tasks, for example, model training and inference. So that's the second way you can incorporate your own custom data into PyHealth. And lastly, I will introduce the third way of using your own custom data. That is, you can always create your own dataset class. So in PyHealth, every concrete dataset class inherits this base dataset class. So this base dataset class is essentially an abstract class that contains a lot of common functions shared by all those different EHR datasets. So what you need to do here is essentially defining two key functions that you need to process your own custom dataset. The first one is called this parse basic info function which will parse the basic patient information, such as the patient ID, the visit ID, and the patient demographics information, and some information about the visit, such as the visit start time, the visit end time, and some visit location or other meta information. So that's the first function you want to implement. And the second one is, depending on how many tables you have, you need to implement one parse function for each of the table you want to incorporate into PyHealth. So this function is called parse table name function, and you need to parse the corresponding table. So let's go to the code and see a concrete example. So as you can see here, I create this customer dataset called HF dataset, and it directly inherits the base dataset, which is from PyHealth. And as I mentioned earlier, we need to first implement a fundamental function called this parse basic info, which will parse some basic patient and visit information. So as you can see in this function, I loop through the events table and create the corresponding visits and the corresponding patient. And also I require the patient ID and the visit ID. So that's what we do here in this parse basic info. And then we need to create a separate function for each of the table we want to process. as I mentioned earlier, in this dataset, we have two CSV files. One is called events, and the other is called HF events. So in this events table, what I did here is I looped through these CSV files and then encode corresponding medical code into a single event for that corresponding visit and that corresponding patient. Well, for this heart failure events, it's a little bit different. So these heart failure events contain the label information for whether the patient has heart failure or not. So what I did here is I will look through the CSV files and then record the heart failure label for the corresponding patient. So that's all you need to do for implementing your own custom dataset. And then you can just simply code this dataset with the same PyHealth API as shown here in this base dataset. So what you need to do is to tell this dataset what are the root folder that contains all the CSV files you need to process, and what are the tables you want to process. And the base dataset will directly loop. Oh, sorry, it didn't show anything because I previously run it once, so it keeps the cache. But if we set the refresh cache to true, you can see it processes this data from scratch. It will first parse the basic info, as I mentioned earlier, and then it will iterate through the events and heart failure events table. So now we finished the processing, and if we print it out, we can see we successfully load the custom dataset into PyHealth data structure. And now let me summarize what we have just discussed. So in this tutorial, I introduced 3 ways to process custom dataset. The first one is, since there is this standard medical data sharing format called OMOP, you can always convert your own dataset into OMOP standard format. However, as I mentioned, this approach may have some drawbacks. That is, it may be very tedious and difficult to convert your own dataset into OMOP, or in some cases, your dataset is not an EHR or medical claims dataset. It may be some monitor data or some other, or X-ray or other modalities that does not fit in the OMOP data format. In such cases, you can do the pre-processing on your own and directly give PyHealth a list of dictionary-based samples, and then call PyHealth sample dataset to adapt your custom data into PyHealth pipeline. And lastly, you can also inherit the PyHealth dataset class and create your own dataset class to do the pre-processing for you. So either way, you can convert your customer data into PyHealth internal structure and utilize other modules of PyHealth, the medical code mapping, the deep learning model, and also the trainer inference pipeline. So that's the end of this tutorial. Lastly, I want to show some resources for PyHealth, including our webpage, our GitHub, and also all those tutorials are recorded. You can find them in our YouTube channel, AI for Health. And for next, we will have another PyHealth Lab tutorial next week, same time, 8 p.m. Central Time. And in next tutorial, we will show you how you can define a custom medical task using PyHealth. So that's the very end of this tutorial. Thank you very much.